Hello, let's continue our Sudoku adventure with St. Nicholas by Palfly Kampling. So we have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. Every line in this grid is a composition line. Composition lines switch between prime and non-prime digits. So if this digit was prime, say a 2, then this digit would have to be non-prime, a 1, 4, or 6. We just every other switch between them. And that's true of all of these lines. Just follow the line as it would make sense. The swirlies and stuff are just to make it look neat. We also have prime killer cages. So these are cages. First of all, digits in a cage can't repeat. So normally we could put 2 and 2 here by Sudoku, but we can't because the killer cage says we can't repeat. Additionally, whatever the sum is of all the digits in the cage, that has to be prime. So we don't know exactly what sum each of these is, but they must be a prime sum. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, I think I'm going to color code prime, non-prime. I think that's going to be very helpful. So we'll just use green, purple. We don't know which is which, but we know these go every other. So we'll just do that. Now, there's going to be 3 primes and 3 non-primes in every row, column, and box. So for example, we know we need one more of each here. And one more of each here. Let's see. There's one of each here. Do we want to think about? Let's color this line two different colors. So red and yellow. Just real quick to see if we can link these. Yeah, we can link them because these 3 are all the same, and we know they're not green. So actually, red is going to be purple. So red is purple, and then yellow is green. Okay, so the rest of this row is green. We need 3 of each. This column finishes with a green. This column finishes with a purple. This column finishes with a green. This is purple. Can we continue? One of each, one of each. Yes, up here's all purple. Okay, we know there's one of each here because of the line. And so that's going to use up all the purples because one of these has to be purple. So that makes this green, that makes this purple. Okay, I think that's all the coloring I can do. If there is more coloring, I'm not seeing it at the moment. So we probably have to think about these prime cages. How do we want to think about this? Are there any cages that are all one color or? Yeah, these at the top are all one color. So we need a so we know this is 2, 3, 5. Sorry. I guess the sum of 2, 3, 5 is 10. Wait. Did I mess up then? Right. Sorry. Because this pokes in. So yeah, we know which is which. Because this cage is all prime or all non-prime, but the prime digits sum to 10. 2, 3, 5 sums to 10. That's not prime. The non-primes sum to 11, which is prime. So these have to be the primes. So the purples are all 1, 4, 6. The greens are all 2, 3, 5. Now, since we know this is 10, this has to be something we can add to 10 and be prime. So it's got to be an odd number because 10 is even. We can't stay even. We need an odd number to make it odd. So this has to be 1. Now this is even, so this has to be odd. So it can't be a 2. These are not 1s. Okay, I don't know. Is there more to do with that? These 2? Well, this is even, so this can't be even. That places this as 2. This isn't 2. Places the 2 here. That's not 2. Let's look at the possibilities here. So if this was a 3, we'd add to 7 or 9. We'd have to be 3, 4. 9 is not prime. Let's remove this too while I see it. If this is 5, then we'd have to be 9 or 11. So we're either 3, 4 or 5, 6. We can't be 3, 6 or 5, 4 because that is to 9 and 9 isn't prime. So 3, 4 or 5, 6 doesn't immediately help me. These add to 10, so we need to be 13 or 15. This can't be a 5 because 15 is not prime. So this is a 3, 13 is prime. So that's 5, 6, because we said we can't do 5, 4. That makes that a 4. So that's not 3, that's not 5, that's not 5, that's not 6, that's not 6. Okay. Get rid of these 4s as well. We know what these add to. These add to 7. So this digit needs to add with 7 to make a prime. So it obviously it has to be even because we have to stay even. So it's 2, 4, or 6. It can't be 4. 7 plus 2 is 9 though. So 7 plus 6 better be prime. It's 13 it is, yeah. So that's 1, that's 4, that's 1. 6 is purple. So that makes this green, which is 2, 3, 5 out of 3. Let's actually get some digits here. These aren't 4. We get our 4 and 6 here. Okay. Rest of this row is green. That makes this purple by the line there. That makes this green. Makes this purple. Okay, we're fully colored. Let's make all our greens are 2, 3, 5. And then the purple, this has to be 1, 6. Okay. The 4 in this column goes here. We have to put a 2 in here because this is odd, so we have to stay odd. 5 or 7 would work. That makes this a 3, 5, and 2. 5, 2, and 3. We get our 5 here. I forgot that this is 4. Okay. Get our 3, 5, and 2. That's 3 and 5. That's a 3. Okay, so this is 7. Can't add 1 to that. That's 8. So that's 6. That's 1. That's 1. That's 6. That's 6. That's 1. And we're done. Fun fact, on the 6th of December, some European countries celebrate St. Nicholas. His Dutch name, Sinterklaas, is the origin of Santa Claus. Nice. Fun fact at the end there. Nice. And of course, today is the 6th, or it would have been if I'd released this on time. Anyway, cool. Well, nice puzzle, Palfly. Let me know how you did. If you enjoyed this, then why not leave a like, subscribe, and a kind comment below.